Okay, welcome to a little support with working with multivalent ionic compounds. Alright, this comes from page 7 in your A2 note booklet. So we'll just go over a little reteach here. Naming using the stock system. The stock system goes like this. Some ions actually can exist with different ion charges in different situations. All right, different ion charges in different situations. For example, you could take iron. Iron can exist as a 3+ or a 2+. So that we can tell the difference from one or the other, we use Roman numerals in the name to indicate which charge we're going to do. So we need to know our Roman numerals. Okay, Fe+3 is going to use iron with a Roman numeral 3 because 3 stands for +3. Fe+2 is going to be written as its name, iron 2+ or Roman numeral 2, to show us that it is the +2. So you can see that's going to make a difference in how it combines with the anion. So the chemical formula for iron 2 would be 2+, and for iron 3 would be 3+. So basically we treat them like two completely different cations, and we have to balance them completely different from one another. Okay, so we'll take a look at this second example here. Okay, we've got gold, and it's got a Roman numeral of 1 with chlorine for the anion. So I would look up gold. On the periodic table, gold can be found right here, okay, Au, and we see that it can exist as a 3+ or it can exist as a 1+. So this is what we call multivalent. It's got more than one possible charge. When it bonds, it either gives away 3 electrons or it gives away only 1. So it's kind of like it's got a split personality, and we have to use Roman numerals to tell which one we're dealing with. So this one I believe said Roman numeral 1, so we are going to use a +1 charge for it. Alright, so when I write this down, I'm going to go gold, which was Au, +1. And in that element there's also chlorine, and chlorine, if you remember, is a -1. So these will bond in a 1-to-1 ratio. A positive cancels a negative. So when we show that, we will write A little u, C little l, and that's it. Okay. In terms of states of matter, we always add those at the end, and those ionic compounds, again, are always solids at room temperature. Okay. The second example is kind of a trick question for you on here, because if you look up aluminum, it's on this multivalent example worksheet, but when we look at aluminum, it is actually not multivalent. Aluminum only has the possibility of behaving in this way. It's going to give away 3 electrons every time. Okay, it doesn't have that possible difference. So this one is not multivalent. That means that it will never need a Roman numeral. Okay? The one below it, gallium, only has one possible way that it can combine. It will always give away 3. So it, too, will never use a Roman numeral. Zinc never uses a Roman numeral. But if you look at copper, copper has 2 ways of bonding. It will either give away 2 or it'll give away 1. So yeah, copper's going to need a Roman numeral every time you name it to show which way it bonded. Did it bond by giving 2 or giving 1? Okay? Alright, so aluminum's kind of a trick question. It's on here, I think, just so that we can teach that difference. Okay, let's look at number 4. Tin has a +2 charge in this case, and I know that without even having to look it up because it's got Roman numeral 2 there. So I might want to look up its symbol, Tin is kind of a strange one. Okay, tin is S little n, and it either can be a +4 or a +2. So in this case, it was a +2. So we're going to use it that way. Tin +2 will combine with oxide, which is oxygen. Oxygen is a -2. So when tin uses +2, it's going to bond in that 1-to-1 ratio. And we would write it simply as SNO. All right, if we were using the +4, I think it was +4, +4 would bond differently. There would have to be 2 oxygens to bond with it. So that becomes a different ratio. All right, so that's the thought process here. Not to make this video go on too much longer. Work hard through them, and as always, ask those questions.